SiFive, the pioneer of commercializing the RISC-V instruction set and resulting IP, has announced a number of custom design wins, and a lot of them leverage ARM technology. In fact, a recent SiFive release revealed that the company has developed SiFive Insight debug and trace IP that features native compatibility with, you guessed it, ARM's Insight IP that serves the same purpose. So, is the RISC-V standard bearer ditching its heritage to become a design mercenary? Or is this a longer-term play to help get RISC-V technology into SoCs in any way possible so it can grow from there? Or are we overthinking it? Drew Barbier, Director of Product Marketing at SiFive, joins Brandon and Rich in this edition of the Embedded Insiders to explain.
Good afternoon. Rich Nass, Executive Vice President with Open Systems Media and leader of the Embedded Computing Design franchise, here for this week's Embedded Insiders with Brandon Lewis. So the last time I talked to you, we were talking about my tree that got hit by lightning. The insurance company is dragging their feet forever. It looked sad last week. It looks incredibly sad this week.
Oh, it's a poor tree.
Yes.
And I'm completely shocked that the insurance company is dragging its feet.
Yeah, right. Imagine that. All right. So we've talked about RISC-V a lot. I was going to say too much, but it's a cool technology. However, I'm going to bring it up again because a release crossed my desk the other day that said that SiFive is announcing a major update to its core IP portfolio. And the way that I read this is that they're integrating the ARM CoreSight bus into their portfolio of products, I guess is the best way to say that. So you can put a RISC-V core, the same piece of silicon, a SiFive RISC-V core into the same piece of silicon with an ARM core. Do you read that the same way? Am I getting that right?
Yep, that seems about right to me.
So the cynical side says, well, they're just hedging their bets and they know that they're not up to snuff. But I actually think this is a really innovative thing because it allows each of these cores to do what they do best.
What is it that they do best?
Well, I would use the ARM core for all the general purpose stuff, and then the RISC-V core for something very specific that just keeps doing that same thing over and over and over again. If I'll use the disk drive controller as the example, you have the RISC-V core just handling the disk operations, and then all the I/O and the other stuff, and you could add lots of other functionality, even an M core. And that makes you a very low cost, pretty high performance controller that can do lots of stuff.
Where did you get that disk drive controller reference from, I wonder?
Well, that's the one, and I happen to use that one all the time because it's the one that's been used most.
By WD.
Right. Who said that they were going to have 1 billion cores and obviously they're going to use it for disk drive controllers. But if you can stick an ARM core into that same controller for literally pennies, let's say 50 cents to add the ARM core in there, now your drive can do lots of other things. And you have a smart drive.
Yeah, that's true. One of the things that
Whoa. Why do you sound so ho-hum about that? I just came up with this $1 billion idea, and you're like, yeah, whatever, I could do that.
Well, I think the $1 billion idea was already had by WD when they decided to not use ARM cores in their disk drives at all and save that money.
Yeah, but now they're putting it, well, they're not putting it back in, but anybody else, yeah, maybe that's not the right example, but a similar example where you have a fixed function and a multi-purpose in this same piece of silicon.
It's probably a win-win. So for RISC-V, from a technology perspective, you have a way of bridging yourself into markets and applications and specific system designs. Hey, RISC-V is here. It's doing this special function, but it's a toehold, right? And then from the customer perspective, great. We can maybe save a little bit of money, and we've got this dedicated piece of IP that is more efficient, et cetera. Now, the other thing is that over the past, I don't know, year, 18 months or so, it appears that SiFive has become sort of this like custom IP design house shop. And at the bottom of the first graph of that same release that you're referencing, it states SiFive Core IP is developed in partnership with customer requirements that include in pre-integrated SiFive, blah, 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 blah. So it's likely that this was something that a special design that a customer was interested in implementing, and they went to SiFive. And when SiFive offered out that RISC-V could do all of this stuff, the customer said, all of our infrastructure is based around ARM. We can use this piece of RISC-V IP as a dedicated accelerator or something, but that's as far as it's going to go. SiFive said, fine, we'll make our RISC-V tech as compatible as possible with your existing ARM stack.
So do you think SiFive will make that CoreSight IP open source? Then you could just go in and take the WD core and the IP from SiFive, and then all you have to do is source the ARM core.
Well, the CoreSight IP is ARMS.
Yeah, but the ability to connect it to RISC-V is SiFive's.
I wonder that. SiFive, of course, has been seen as the leader in RISC-V technology basically since its inception. And it sometimes confuses me who's going to be the standard bearer here. If SiFive is moving more towards becoming a custom, IP house, helping customers design these application-specific chips, then what is the incentive for them to open source that type of technology? And if they're not going to open source that type of technology, what does that mean for the rest of RISC-V and the RISC-V ecosystem if they're the big 100-pound gorilla of RISC-V is becoming sort of a niche player?
First of all, your 100-pound gorilla is going to get thrown out the door pretty quickly.
Oh, I'm sorry.
But I don't think
that is the cow running into the street.
Exactly. I don't think that's the case. The big bucks are not in design services. The big bucks are in selling millions and hundreds of millions of cores, and I would bet that that's where they're headed, and that's where their investors want them to go.
Well, that's where their investors want them to go, but this entire conversation, is this an admission that maybe for the foreseeable future, there isn't the opportunity to license hundreds of millions of cores? In the short term and midterm, maybe the opportunity is to do these specialized projects, help push RISC-V onto an SoC where it's not the only piece of IP, and not even that, not even the main piece of IP,
I don't see why that can't be a mass market device. I mean, I'm thinking that you can almost replace your programmable logic to do that, that was doing the fixed function stuff with the ARM core with the RISC-V core.
Yeah, I agree with that. But I'm saying right now, we're talking about one announcement and one instance of this. I mean, in essence, this is a corner case right now.
Oh, I have grand plans for this. I'm thinking years down the road.
Well, yes, that's why I said short-term, midterm. Going back to the top, I agree. What better way to start getting yourself a lot more exposure than just saying, hey, ARM, you rule the roost, and just give us our little corner over here, and we'll handle these, basic housekeeping things maybe, or specialized functions. In the future, maybe that grows into becoming something more.
Yeah, I think they want that to happen sooner rather than later. I think there's too much invested to have a strategy that's very long term.
I'm sure the VCs on Sand Hill Road think the same thing.
It isn't as interesting when we both agree on the same topic, but when you recognize that I'm right, I mean, I can see that.
For all the listeners, I told Rich all of my thoughts before we got on the
call. Now, the insiders are joined by Drew Barbier, Director of Product Marketing at SiFive.
Now, is he going to tell us why that they need ARM in the same piece of silicon with RISC-V to make this successful?
Jumping right into it, I see. ARM CoreSight is an architecture just like their instruction set architecture, but it applies specifically to debug. So it defines the interaction between all the different debug components in the system, how the tools, like from the JTAG vendors, for example, would talk to the cores and set breakpoints and things like that. ARM CoreSight compatibility allows our solutions to plug into ARM CoreSight infrastructure. And the reason why this is important is SoCs are complex, right? Yeah, there might be a Cortex-A core in the SoC, and that might be the main marketed core that's there. But in addition to that, there might be 10 or 20 or even more smaller auxiliary cores all around the SoC doing different things like power management or accelerator type functions and so on. And so it's natural for RISC-V to assume a lot of that functionality first. And we've been pulled in that direction by our customers a lot. And so the CoreSight compatibility that you saw us talking about as part of the 20G1 launch, a lot of that was just listening to what our customers wanted and helping make their lives easier. Because at the end of the day, they are choosing our IP on its own merits for these specific functions that they're wanting to integrate with. But they do integrate into these larger SoCs, and a lot of that infrastructure is still ARM, and in the case of debug, CoreSight. And these CoreSight systems can be quite complex, and customers don't want to rip that out or put in brand new infrastructure to be able to accommodate dipping their toes into RISC-V and seeing how that goes. So by adding CoreSight compatibility, we make that transition a lot smoother and a lot easier for SiFive's customers.
Funny question for you, Drew. Is SiFive an ARM licensee?
Is SiFive an ARM licensee? So it's a little bit complicated. So we have different business units within SiFive, and certainly we have the Silicon business unit, which came from our Open Silicon acquisition, and they were or are an ARM center of excellence, right? So they do ASIC designs for a lot of different customers, and in the past those have been ARM designs.
I mean, I'm really taking this out to the nth degree here. You could produce a microcontroller that only has ARM silicon in it and doesn't have RISC-V.
So SiFive as a company, we don't put out ASSPs or catalog devices that people can go and buy. We have some development kits that we produce to help the ecosystem and to help silicon prove our IP. And those are, of course, RISC-V based. On the ASIC side, we can have customers that have SiFive cores, that can have ARM cores, or other accelerators in the ASIC. Those are ASICs, those aren't SiFive devices, right? They don't have SiFive on the label.
Are you seeing most of your RISC-V cores now being used in those peripheral, like general housekeeping type of use cases? And if so, where do you see the most uptake?
Yeah, so I think it's pretty natural up until I would say mid last year. A lot of the traction in RISC-V was in designs where customers were in full control of sort of the entire software stack. So this could be anything from microcontrollers that you could buy from anywhere, all the way up to these sort of fixed function devices. It just takes time, right, for the larger Linux software ecosystem to mature, so you can hit these more sophisticated software stacks. But since sort of mid last year, we've seen that start to take off, and customers willing to start taking the plunge on the higher end as well. So you'll start to see devices over the next year and a half in these higher end spaces in RISC-V. But yeah, it's natural for the smaller devices, the more simplistic software stacks to take the first step. And I think that plays naturally into sort of SiFive's CPU portfolio as well, right? Because we have this entire portfolio of tiny microcontrollers all the way up to superscalar processors. And we have out-of-order cores coming out in the future, as well as vector-type cores as well. You'll hear this in big cores and out-of-order cores, a thing called micro-ops, where they'll take an instruction and break it up into 2 or 3 different actual instructions that the pipeline then executes. RISC-V, the ISA is simple enough that you don't have to do that. And that plays especially into out-of-order processors and scheduling and things like that to allow you to build a lot of these high-end machines a lot more efficiently. And then where you do need specific acceleration, RISC-V gives you the ability to extend the ISA to add exactly what you need, not a handful of instructions that may or may not be what you need. So I think the simplicity coupled along with sort of this domain-specific approach to enabling some of these accelerations for HPC type workloads, I think is overall a much better fit than maybe a more complex or sophisticated base of architecture. So you can see with where we're going with the products, where we're being pulled by our customers.
What does it look like in terms of SiFive licensees?
So I don't have the exact numbers in front of me, but I believe last year we put out some press that we had 100 plus design wins at the time. So as you can imagine, that's after really being in business for maybe 2 years. You see a lot of traction in the low and mid-end part of the portfolio, especially because of the reasons I outlined earlier. You know, the higher end of the portfolio is starting to gain traction as well.
Is there any concern that some of your, I'll say competitors, but I guess they're competitors, don't have the same traction that you guys have? You guys seem to be well out ahead with RISC-V.
Everybody has RISC-V projects going on right now, and whether or not they're licensing from SiFive or licensing from another commercial RISC-V vendor, I can't really speak to, but certainly we had lots of engagements with SiFive IP and potential customers, and I would have to imagine that other RISC-V companies probably see similar things. Although I think a lot of that plays into just the strength of SiFive's IP portfolio. We do have this expansive portfolio that is getting bigger all the time. We have all of this complementary IP that goes along with the cores as well, because at the end of the day, you can have the best CPU possible, but if you don't have all of these other things that customers expect and require really to do their jobs, then it's really difficult to consume that IP. And at SiFive, we have all of this, right? We have.
That was sort of my point, that you guys are, I hate to say it, but doing too good a job in that you need competition. If you don't have competition, you don't want to be the only RISC-V vendor out there.
Yeah, agreed. If there's only one vendor, then it just turns into another situation like we've been in for the past decade, right? So I agree. And we participate in the RISC-V International and all the foundation forums to try to promote the architecture. And I think you'll see a lot of activity. It's not just SiFive. So I think you'd be surprised if you actually went to like the mailing list or the summits and just see how much activity there is. At the end of the day, SiFive is still a relatively small company, right? There's only so much.
So we should stop talking about SiFive, Brandon, and just prop up all the competitors going forward. That'd be great for SiFive.
Right.
Thanks for listening to this edition of the Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.